So we want to use the graph of the absolute value of x. This is one of the graphs that we know, and we know some points on it, to graph y minus 2 equals negative square root 3 x plus 3. So the first thing you would do in a question like this, you'd say, well, we're more used to having the 2 on the other side. So that would probably be the first thing that you would do, is you'd move that 2 over. Then after you move that 2 over, remember in the last example that we made a note that this was already in factored form just so that we thought about it. In this case, this is not in factored form. So I don't know if anybody set that reminder at 10 p.m. last night to tell them to think about that. But right now, that's not in factored form. When we have a horizontal, in this case compression, and a horizontal translation, we always have to write it in factored form. So what does that mean? It means that inside here, I'm going to factor out the 3. That changes this to x plus 1 plus 2. After factoring it, now this is in the form that we're used to. We can go from left to right and just label what everything is. So the first negative, inside the function or outside of the function? Outside. So outside is going to be vertical, and a negative is a reflection. The 3, inside the function, horizontal, and it would be a horizontal compression, and we'll write down, maybe I'll write it at the same time. This means we're going to multiply y by negative 1. This means that we're going to multiply x by 1/3. The plus 1 is a horizontal translation. That means we're going to go 1 to the left. And the plus 2 outside the function is a vertical translation. We're going to go 2 up. Once we've figured out everything that we are going to do, we're going to take key points from the original graph and then see where they end up. Now, a really important point on our original graph is 0, 0, because that's where our square root graph starts. So for sure, we're going to use 0, 0. Other points on our square root graph that we know: 1, 1, 4, 2, 9, 3, or 9, 3 would actually be right there. 16, 4. Those are all values that we know on our basic square root graph. Again, you either know those values or you can figure them out by just saying, what are nice numbers that I can take the square root of? Square root of 9 is 3, square root of 16 is 4, square root of 4 is 2, and so on. So when choosing another point and thinking about all of our things that we're doing, okay, there's going to be another point that works out nicely with whole numbers. See if you can figure out which one that is. I'm going to show you a point that doesn't work nicely, just so that we work through it as well. So, for example, 4, 2 doesn't work out that nicely. We'll get some fractions. But can you figure out the point that will work out nicely? 9 and 3. So we'll do that one as well. When setting up your transformations, we do one set of arrows for all of our stretches and one set of arrows for all of our translations. Going from left to right, we have y by negative 1 and x by 1/3. Those are all our stretches, compressions, and reflections. And in our second set of arrows, we're going to go 1 to the left and 2 up. So x by a third, 0. This will become 4/3. 9 times a third is just 3. So you can see why I might have wanted to avoid that second point, just because it has fractions. It's not bad to have fractions, but the other point is going to be nicer. And y by negative 1, this is still 0, 0. This becomes negative 2. This becomes negative 3. Next we go 1 to the left. How do you go 1 to the left from 4/3? We have to minus 1 from 4/3. How do we minus 4/3 minus 1? Subtracting fractions, you need to have a common denominator. So you probably change your 1 to 3/3. 4/3 minus 3/3, 1/3. And then moving everything 2 up, this will be plus 2. This will be at 0. This will be at minus 1. So if I go to sketch the graph here, and I'll sketch it on a separate grid off to the side, negative 1. So I have negative 1 comma 2. I have 1/3 comma 0. So for 1/3, you're just going to estimate approximately between 0 and 1 where 1/3 would be. And I have 2, negative 1. Finally, we have to draw this graph. The key thing is we know that this was the starting point, so that means this is the starting point of our transformation or our image graph. So if that's the starting point, connect the points, have the same general shape that you began with. And for helping you with the shape, look at the shape that you started with, and then think, if I have a vertical reflection, this. Okay. All right, if I have a vertical reflection, that would flip it down. It would end like that. Then a horizontal compression, that would make it wider. It would go like that. Move it 1 to the left. Go there, move it 2 up. Approximately like that. Does that kind of match up with what we have? Yes. The important thing is I figured out that the shape was like that. Because sometimes you'll have 2 points and you'll wonder, should I do it like this or should I do it like that? And that visual will help you.
Can I have the unit circles?
Yep.
The actual project one?
So now that we've got both graphs, this question says, what is the domain and range of our blue graph? So we've drawn it. We can look at our graph. Usually a graph is the easiest place to see domain and range. The smallest x value is negative 1. I'll do it in interval notation, so it starts at negative 1. Oh, I'm still using my pen that erases. Do you like the pen that erases? From 1 to infinity, and the range has no smallest value because that arrowhead means that it's going to go down forever as well as going to the right forever. So our smallest value is negative infinity. Our largest value is 2. Questions for practice are 8 and 10.